Calculator FRQ. A rare species of fish has been found in the Everglades. Scientists have relocated the fish into a protected area. The population P of the school of fish T months after being removed is given by. So they give you an equation, and this is telling us how many fish. Population is our Y values, okay? And T are the number of months after they move them. Shh, guys, you probably want to pay attention to this FRQ. So first thing is to put this in our calculator. You must clear your RAM for the 5 millionth time, and we're going to type this in. Now, guys, how you type this in is very particular. I cannot help you on test day on how to put something in your calculator. You have to know how to do it, okay? And so the question on the test is going to look just like this. Shh, please stop talking. It's going to look just like this, but different numbers, okay? And understand that 375 out in front, if you wrote it as a fraction, it would be like 375 over 1, right? Why I'm saying that is because that tells you the 375 is really part of the numerator. But anytime you're part of the numerator, you can kind of be written out in front too, and that's what's happening here. So we're going to type 375 and then open a set of parentheses and type our numerator. And you're going to close your parentheses. Okay, so I put that in as 375 times 1 plus 0.5x, close my parentheses, that's where I am right now. And then we want divided by, so hit divided by, and it makes that little, and you're going to open a new set of parentheses and put your denominator. And you can either close your parentheses here or not. It doesn't matter. Since you're going to another screen, it would close it for you. Okay? Now, the first question is how many fish were found initially? How many fish were found initially? So, how many fish, that's your Y value, number of fish. Initially is time. That means before we move them or before time started, so that would be 0. So when X is 0, what is Y? Anytime you're given X and you need Y, you can just go to the table. So second table, and right there at the top, at X is 0, there were 125 fish. Okay. The next question, what will the population be? So what is Y when we have this much time go by, 5 years? But remember, years is not what we should be finding, it's number of months. Time has to be in months. So we have to convert 5 years to a number of months. There's 12 months in a year. If you know 12 times 5 is 60, fine. You don't have to show any work, but we do need to know it. So if you have to use your calculator, totally fine. You don't have to show this for points. I know we get nervous leaving a screen, but trust me, if you go to your regular computing page, like your home page, all this will still be there. You don't have to type it in again. And how do we get out of here? You can use your quit button. See how it's blue? It's right next to the second. If you hit second quit, it just brings you back here. But don't worry, what you typed in there is still in there, okay? So I'm back on this page. 5 times 12, if I needed to use my calculator, I know T is going to be 60. So the question is, after 60 months, right, after this X value, what is the population? Again, I'm going to use my table, okay? And my table is still there. I just go back to my table, and I want to get to 60. You can arrow down 100%, or if you press the plus button and type in 60, it'll jump right there. Okay, so see how it says press plus? If I hit the plus button, I'm going to put 60 there and hit enter. It'll give me what 60 is. And I'm going to say, I change the directions on the test to say round your answer to the nearest whole fish. Okay, so you can see on the chart it says this. I'm going to round that, of course, to 2,768 fish. Okay. The next one is use limit notation to state the end behavior of this population. And we don't need, in a real world problem, I wouldn't take points off for it if you did it, but I won't bother grading it. All we need is the right side limit behavior, because we know, like, to the left, there was 0 fish at one point, and then it grew to what? What's the max number of fish? That's your horizontal asymptote. If you remember, a lot of times people call HAs end behavior asymptotes because it tells you how, it limits your Y values. It stops your Y values. And if you remember, the way we find horizontal asymptotes is to look at the degree of the numerator and the degree of the denominator, okay? So in this question, this was given to us. The degree of the numerator was what? What's the degree of the numerator? What's the biggest exponent we have in our numerator? 1. That's a 1. What's the degree of our denominator? 1. Okay, let me remind you of something, because there was a lot of quiet when I asked that question. You're used to seeing like something like this. And I would say, what's the HA? And you would go, oh, I look at the numerator and the denominator's degree. When they're the same, then I look at the leading coefficient. So my HA of a problem like this would have been y equals 2 over 1 or 2. Right? You're used to seeing it like that. Same idea. 1 over 1. When they're the same, we have to look at the numbers in front. But be careful, because our numerator is in factored form. I need to distribute that. My numerator, sorry, I'll go over here, would be 375 plus. So 375 times 1 is 375. 375 times 0.5, I did it in my calculator, not in my head, would have been 187.5. Okay, so I needed to do that to get my true leading coefficient right there. Didn't do anything to my denominator. So now looking at it, this is 1 and this is 1, just like it was before. Distributing the 375 did not change the degree, okay? But now we know this is the number in front of the numerator's t, this is the number in front of my denominator's t. And it's normal to have weird numbers like this. This is real world math. Like, it's not going to always be perfect, like 2 over 1 is 2. It's weird numbers. I can put that in my calculator, 187.5 divided by 0.02, and that is my horizontal asymptote. That's the highest number of fish we're going to get according to our equation, okay? So how do we write the limit notation? The limit of the name of this equation is P of t. Where did I get that? Right here. As x approaches, and remember, we only care about the right side, so that's infinity, as x goes to the right, is 9375. That is your answer. And so think about this, like science and math go together quite a bit. We're on the math side. We are doing the math, and the scientists take our math and they interpret the results deeper than we do. But so this is like the math, but what does that really mean? And that's what part D is. What is the largest population that the new area can sustain? So that is just this number, right? Think about it. If you graphed it, which I never even bothered looking at the graph. It doesn't matter to me really what the graph looks like, and I'm not going to bother with changing my window to really see the graph. I don't care. I didn't need it for anything. But the highest it will ever get would be this, because that's your horizontal asymptote. So 9,375 fish. So we just use that number as a maximum. The largest number. Can't go above that because there's an asymptote that stops you from going any higher. Okay? So this is exactly, the question will be exactly the same. Okay? We do have time if people want to ask me for other questions. Like, I think I heard a lot of 13s. Is anybody wanting 13 done? Yeah. I'm going to do 13. It's a lot easier than what it looks. But you do have to remember the calculator steps. Clear your RAM. Guys, this comes from the very last section that we did, which was where you had to use your stat enter and your stat plots and all this. What they're asking is, here's some data. Let's put it in our calculator. And should we use a linear or a quadratic model to model it? That's what it's asking. How do I know that? Because I looked at the choices. Some of them are linear, some of them are quadratic. So we go to stat enter, and you're going to type in your x's and your y's. Okay, so I did that. Then you go back to stat. Evan, I would just watch me do it right now, and then this is on the recording, so you could go back and watch this. Okay, so then I'm going to go back to stat, over to calc, and I want to know linear and quad. So I'm going to have to do this twice. I'm going to go, doesn't matter which one I do first. I'm going to do linear first. Remember how to store it. Alpha trace enter. Okay. Now I know it's saved in the calculator. It's right here, okay? So is that my answer? A, let's see the 1695.2. Okay, let's see. Let's go back to stat, over to calc, and let's save it as a quadratic, because there's also choices here that have x squared. So quadratic. I'm going to store it, but instead of storing it at 1, I'm going to store it like at 2. Alpha trace, because I already have something in the spot of y. So y2, enter, enter, enter. Okay, so if I go to y equals, now it's stored in y2. There's my linear and there's my quadratic. So just doing that, you know the two choices. It has to either be A or B, because that's the linear one, that's the quadratic. These are out of the running. How do I know which one? Well, I need to see these both graphed. Remember which one hits all the points best? So you have to turn your stat plot on. Second, stat, enter, enter. So now you can see the stat plot is on. And then you have to go to zoom, find the one that's got stat in it. It's number 9. And now, there's the line. There's the quadratic. Which one is better? Yep, so that's how I knew to choose B.
I'm going to read all of them. I don't remember all of them.
I am going to write some hints to you, but it's by practicing. Yeah. How come? Okay. You don't have to show any work, obviously, so I'm not really sure what you're saying, but if I believe you that... Well, I don't know what you mean by regulation.